Hi, Amanda. We're going to start off with, sorry, ignore that. We're going to start off with U1. Now, U1 is pretty self-explanatory. It's just going to ask you which of these represents whatever term they're asking. So here it says, which figure shows a sector? A sector is the area of a part of a circle. So that would be this one here. Here it says, which figure shows a central angle? A central angle of a circle is an angle that comes from the center. That's why it's called a central angle. So this would be the central angle. Which figure shows a chord? A chord is a line that goes, or a line segment rather, that goes from one edge of the circle to the other, but does not go through the center, because that would be the diameter. So this is a chord. Which figure shows a diameter? Now that is a line segment that goes through the entire circle, but it goes through the center of the circle. So this is a chord, this is the diameter. Which figure shows the center? The center is that point in the center. Which figure shows an arc? An arc is a part of a circle, so it would be this one here. Which figure shows a radius? The radius comes from the center of the circle to the very edge. So it's half of the diameter. So it would be that one. And then it just kind of repeats because those are basically all parts of a circle. So which figure shows a sector? That was like our first question, which would be this one. And that's it for IXL U1. So let's go to U2. Now U2 is finding the measure of those angles or arcs. So first of all, whatever angle is, whatever your central angle is going to equal to the arc measure. So this angle that's 150, that's going to be the measure of this arc here. And this is not part of this question, but it's just so that you understand for the rest. So this angle here that's 80, that means that this arc here is 80. Now what they're asking for is the measure of angle EGF. So that's this angle here. Now as you can see, all of these angles here, it creates your full circle. And a full circle, we know, is 360 degrees. So in order to find the measure of that angle, we do 360 minus the 150 minus the 80. And if you do that, we get 130. Now over here, it's asking for the measure of the arc VW. So that's this arc here, V to W. Now just like here, the sum of all the central angles is 360 degrees. It's the same thing for the arcs. The sum of all of the arcs is 360 degrees. So we do 360 minus the 130 minus 100. 360 minus 130 is 230 minus 100 is 130 degrees. So it's basically the same thing, just kind of repetitive up until you get to a score of 60. So we're just going to do a couple more here. Here we have these angles and we're trying to find FJG, which is this angle here. So we have all of the angles, so we do 360 minus 120 minus 140 minus 50, and that's going to give us the measure of that angle. So 360 minus 120 is 240 minus 140 sorry, is 100, and then 100 minus 50 is 50. Over here, they're trying to find the measure of the arc GH. So just like the other ones, we do 360 minus 125 minus 140. And when we do that, 360 minus 125 minus 140, we get 95 degrees. So that's basically U2. There's really not much more to that. So let's look at U8. In U8, you're going to be asked to find the lengths of either the chord or the arc. Now, the one thing that you need to remember is if whatever the chord, the arc that intercepts the chord, if they are the same, you see how here you have the line here and the line here? That means that the chord lengths will be the same as well. So if PQ is 34 and it has the same arc as RS, then the chord RS is also going to be 34. So here we're looking for the measure of the arc DE, which is this arc here, which intercepts this chord, which this chord is the same as this chord. So because these two chords are the same and it intercepts this arc, if this arc is 85, then this arc will also be 85, which is what it's asking you to find. Now over here, it's asking for the length of DE. Now, even though we don't see the markings, we see that this arc for this chord is 50, and the arc for this chord is also 50. That means that these chords here are the same. So since BC is 30, ED or DE is also 30. Now here we're looking for the length of the of the segment QR, which is this one here. So you're given these two circles. Now we see that this arc here, this big one, ST, is 273 degrees. But here we're given this arc here, which is 87. But if I try to find the measure of this arc, that would be 360 minus 273, which is equal to 87, which is the measure of this arc. So that means that these two chords here are the same. So if this one's 42, that means QR is also 42. All right, here's another example of just that. We have here the measure of minor arc YZ. That's what we're trying to find. So we're looking for this. Now we're given this big one here, which is the 283. And these chords are the same. So that means that this arc is going to be the same as this arc. So since this whole thing is 283, I would do 360 minus 283. Because remember, a full circle is 360. So when we subtract, we get 77. So that's this chord. So that means that this chord is also going to be 77 degrees. Now this was the last question that I got here. It said, what is the measure of angle XUY, which is this angle here? Now what we notice is that this angle, these are not vertical angles, so we can't assume that they're the same, but we see that this intercepts this chord, which is the same as this chord. That means that this arc measure is the same as this arc measure, and the arc measures are equal to the central angle. So since this is 70, this is 70, and this is 70, that means the angle must also be 70. So that's U8. Now let's look at U9. It says KM is tangent to circle J. What is the value of JM? So we're looking for this. Now what you need to know about tangents, a tangent is a line that touches the circle at exactly one point, which as you can see is this one here. Whenever you draw in the tangent, it's always going to be perpendicular to the radius, which is this here. So what we end up with is a 90-degree triangle. So if you're trying to solve for a missing side, you're going to apply the Pythagorean theorem. These are your legs, so this is A and B. So we would do 3 squared plus 4 squared is equal to x squared. 3 squared is 9, plus 4 squared is 16 is equal to x squared. 9 plus 16 is 25. and then you square root both sides, and you get that x is equal to 5. So that means that the length of JM is 5. Over here, XY is tangent to circle W. What is the measure of angle Y? So this is what I'm trying to solve for. Now remember, this is a tangent, and it's always perpendicular to the radius. So this is a 90-degree triangle, but all triangles have to add up to 180. So we would do 180 minus 90, because of this here, minus the 64, and that's going to give you this leftover angle here, which is equal to 26. You can also do, since this is always going to be 90, you can just always do 90 minus the 64, and that's going to give you the 26. Let's look at a couple other examples. So here we have that WX is tangent to circle V. What is WX? So again, this is an example where we have to use the Pythagorean theorem, since we're looking for this side length. The tangent forms a 90-degree angle with the radius. So this is 6 and the hypotenuse is 10. So that means that we're trying to solve for one of the legs. So when you plug it in, it would be 6 squared plus, I'm just going to call this B. So B squared is equal to 10 squared. 6 squared is 36 plus B squared equals to 100. Subtract the 36 to both sides, and you get B squared is equal to 64. Finally, you square root, and you get that B is equal to 8. So WX is equal to 8. In this last one here for this IXL, we have, again, the tangent and the radius. So this is 90 degrees. And we are looking for the measure of angle F. So if this is 90, that means that these two here have to add up to 90. So you can do 90 minus 23, which is going to equal to 67. So that is the measure of angle F. And that's basically it for that IXL. Now let's look at U10. U10, we're going to start finding segment lengths depending on those tangents. Now, one thing to keep in mind about these tangents is this is that tangent point here and here. The two tangents that are like connected to each other, this is the same as this. So this value will be the same as this value. So it's always like the two that are connected to the outside point, and then those two tangents, they create the same segment. And so this one here will be the same as this one here. So we're trying to find OP, which is this one. So I'm going to call that X. Now this is what you need to do. If this is 9, then this side is 9. Now they tell you that all of this is 17. So to get this piece here, 17 minus 9 is 8. So if this is 8, this is 8. Now here they tell you that the whole thing is 11. So if this is 8, that means that this is 3. And if this is 3, that means that OP is also 3. Let's try that again. Here we're looking for QV, which is this one. So this is the same as this one. This is the same as this one. And this side is the same as this side. So since I know that this is 2, that means this is 2. Since this is 6, that means this is 6. This whole thing here is 9. So we would do 9 minus the 6 to get the leftover, which is 3. So if this is 3, this is also 3. In this same IXL, you are also expected to find the perimeter. In order to find the perimeter, you need to know what all of those segments are, and then you would just add everything together. So if this is 10, this side here is 10. If this is 17, this side here is 17. This one is 14, so this side is 14. And then if this is 10, this is also 10. So now the perimeter is when you add this 10 and 10, 10, 14, 14, 17, 17, and 10. So we're going to add all of this together. So let's start. 10, I'll just write it all out. 10 plus 10 plus 10 plus 10 plus 14 plus 14 plus 17 plus 17. So now I'm just going to put that into the calculator. Plus 14 plus 14 plus 17. And we get the total is 102. Now we do the same thing here. So we have that this is 9, so that means this is also 9. This is 18, so this one is 18. This is 8, so this is 8. 16, 16. So now we're going to combine all of these numbers, adding them together, and that's going to give us the perimeter. So 9 plus 9 plus, you can also do, there's two 18s, so I can do 18 times 2 plus 8 times 2 plus 16 times 2. Up to you. It's really the same thing. So we have 9 plus 9 is 18, plus 18 times 2 is 36, plus 8 times 2 is 16, plus 16 times 2 is 32. And we get a total of 102 again. So that was as hard as it gets for that IXL. Now we're going to look at U12. For U12, we're looking for the measure of inscribed angles. Now, all of these triangles here in the IXL, it says that all of these are right triangles. So that means that we look for where the right angle would be. This would be the right angle. That means that this angle here and angle Q would add up to 90 degrees, since 90 plus 90 would give you the total of 180. So you could do 90 minus 53, which is equal to 37. So that would be the measure of angle Q. Over here, this is the right angle. So if this is 60, that means that this must be 30, because 60 plus 30 is 90. Then after you do those that are pretty straightforward, then they'll start incorporating X. And this is as hard as it gets as well. So you're going to get these two angles, which these two angles have to add up to 90, since this is 90. So we would do 56 plus 17x is equal to 90. And then we solve for x. So subtract the 56. You get 17x is equal to 34. And then divide the 17. So we get x is equal to 2. Over here, this is also 90. So that means that the 4x plus the 6x has to equal to 90 degrees. So we add these two together. 4x plus 6x is 10x. And then we divide the 10. So x is equal to 9. And that's it for that IXL. So let's start here with U11. Now in this IXL, you're trying to find a missing angle depending on the angle that's given on the edge of the circle. Now the relationship here is that the central angle here that intercepts this same arc is going to be double of this angle here that also intercepts this arc. So if this is 33, you multiply 33 times 2 to get Q, which would be 66. Now over here, you have this central angle, which is 67. Now these you kind of gotta play around with it a little bit. So if this is 67, that means that this arc measure is also 67. Now we're trying to find this angle here. Oh wait, I don't know why I'm doing, sorry. Yes, we're trying to find this angle here, TUV, this one. Now that angle, I'm going to show you in a different color, intercepts this arc here. Now if this arc is 67, then this arc is going to be 180 minus 67. Since you can see here, this is a straight line. And so the entire thing would be 180 degrees. So we would do 180 minus 67, and that gives us 113. So if this is 113, then the angle TUV, this one, which intercepts that arc, is half of 113. So 113 divided by 2 is 56.5. Now these we're going to do several examples because it does get a little bit, like that last one can be kind of confusing. So here we're looking for SUT, which is this angle here. And you see how this angle intercepts this arc. So this is 94 degrees, that means this is 94 degrees. This same angle here also intercepts the same arc. So in order to get this one, this angle is going to be half of the arc. So we would do 94 divided by 2, which would give us 47. For this, we're trying to find the measure of angle GIH. So here's G, here's I, and H, so we're looking for this angle here. Now this angle is going to be half of this angle. So we need to figure out, I'm going to put here half of angle GJH. So we need to figure out what that angle is. Now luckily for us, we're given these two angles. So this creates a full circle. So we would do 360 minus 137 minus 127, which when we do that, 360 minus 137 minus 127, we get 96. So if this angle is 96, this angle is going to be half of that, which is 48. Now let's try this one, like a question like this again. We want to find the measure of angle EDF. So EDF, that's this angle right here. Now we're given this 98 degrees, which is the same as this angle here, or this arc. Or you know what? You don't even need the arc. Let's actually start over. It's actually easier to see over here. This creates a straight line. So I could find this angle, which would be 180 minus 98. And 180 minus 98 is 82 degrees. So this is that central angle, meaning that this arc here is 82 degrees. And the angle that we're trying to find intercepts that arc. But remember that this angle that's on the far edge is going to be half of this one here. So 82 divided by 2 is 41. Okay, over here we're trying to find the measure of angle GFH. So this angle. And this is like the other one that we did. This angle is going to be half of this angle. So it's going to be half of the measure of angle GEH. So I need to figure out what that angle is. But again, we have these two. So in order to get this angle, we're going to do 360 minus 76 minus 152, which we get 132. So if this is 132, that means that this angle is going to be half of that. And half of that is 66. Now we're going to move along to U13. In U13, we're trying to find the missing angle of an inscribed quadrilateral. Now, the one thing to remember about this is that opposite angles are supplementary. So if I want to find angle E is going to add up to 180 when you add 102. So angle E is going to equal to 180 minus 102, which gives you 78 degrees. So over here, it's going to be the same thing. If this angle is 98 degrees and we're looking for angle J, which is across from it, that means that angle J is supplementary. So we do 180 minus 98, which is going to equal to 82. All right, then after a while, you're going to get where you have multiple angles to solve for, but it's the same principle. To solve for angle S is across from Q. So you would do 180 minus 67, which is going to give you 113. And then angle T is across from angle R. So angle T is going to be 180 minus 104, which is 76. Last one here, we want to find the measure of angle G and H. So G is across from the 109, so G is going to be 180 minus 109, which is 71. And then angle H is across from the 89, so that's 180 minus 89, which is equal to 91. So that's that IXL. This last one is U14, which here we're going to find still missing angles, but we're giving different information. So here we're trying to find the measure of angle B. Now what you got to pay attention to is that angle B intercepts this arc here. So all of this. Now what we're going to do is we're going to use the other angle that's given and see what arc that intercepts. So here's the 94 and it intercepts this arc here. If you're not sure of the arc that it intercepts, you just look at where the angle is located and follow those lines. And then that's the arc. So if this is 94, sorry, I cut it off, then the arc measure is double the 94. Because remember that this angle, which is way far back, is half of the central angle, which is equal to the arc. So to figure out this entire arc, we would do 94 times 2, which is 188. So the whole thing is 188. But what I need to figure out is this one. Because if I know this one, then I have all of these arcs that I could then subtract from 360 to get the leftover, which is this angle here. And then I'll get to that. So we just want to find all of these measures. So we do 188 minus the 112 to get that leftover piece. So this piece here is 76. Now I want to figure out this leftover arc. So that one there, like I said, we have all of these. I'm done with that. We have the 48, the 112, and the 76. So to get that leftover, we would do 360 minus 48 minus 112 minus 76, which would give us 124. So now, how do I figure out the measure of angle B? B is this angle here, which includes this arc here. So that's the 124 plus the 76, which when you add them together is 200. but this angle is going to be half of the arc measure. So half of 200 is 100. Now over here, we're looking for the measure of angle D. Now for D, I'm going to look at the arc measures that it intercepts, which would be, follow along, so from here to here, so it's this entire arc. So what I want to do is I want to figure out what this one is, because if I know this one, then if I add it with this one, I get the total and then divide it by 2 to get angle D. So we got to figure out a way to get that. So I'm going to look to see what angle I'm given. As you can see, we're given this 101, which intercepts this arc here. So the arc measure is double the angle measure. So if this is 201, that means that the arc is 202. The whole thing. But I have that this one is 78. So what I do is I'm going to subtract 202 minus 78, and I get that this one here is 124. So now that I know that, and we're trying to figure out the measure of angle D, again, that's this whole arc here. I'm going to add these two together. 108 plus 124 gives me 232. So then the angle is half of this measure. So 232 divided by 2 is 116. Okay, for this one, we're trying to figure out the arc measure CD. Okay, so this is what I want to know. Now, we got to use whatever information we have here. Let's start off with figuring out, like we want to find all of the arc measures that are given. So this first angle with the 74, this intercepts this arc here. As you can see, this line ends there, this line ends there. So this whole thing is 74 times 2, which is 148. Now, with the other angle, the 91, that intercepts from here to here, because that's where that angle ends. So this is 91, so the arc measure is going to be double. So 91 times 2 is 182. But what I have here is that part of that red is 141. So I would do 182 minus 141, and that gives me this leftover bit, which is 41. Now, since I want to find the measure of CD, which is this part, since the blue, I know that it's hidden underneath, but the blue, which is the 148, is all of this. So I can take this 148 and subtract the 41, and it gives me what's left over, which is CD. So 148 minus 41 is 107. Last one here, we're trying to figure out the arc measure of AD. So this is what I want to know. Now, we need to figure out what we got here. So let's see where we can start. Okay. Sometimes, right, I'm not going to lie to you, there's really no clear-cut way as to how to solve these. Like, there's no, like, set method. You kind of got to get a little creative and just do whatever you can. So, like, for example, here, I'm going to start with this 93. And I just chose that randomly. So I look at where the 93 ends. So that's here and here. So that's this arc. Let me erase this bit so it doesn't look like I'm including that. So the 93, that's half of the arc measure. So I'm going to multiply it by 2 to get the actual arc, which is 186. So that's all of the red. Now for, let's say, the 136, that starts here, right? Because it starts there and then it ends here. This is 136. That means that the blue is double of that, which is 272. Now I am told here that this part of the blue is 128. So I can get this part of the blue by subtracting 272 minus the 128, which gives me 144. So that's this. That is 144. Now if that bit is 144, I can get this bit here, the leftover red, by subtracting 186 and 144, which gives me 42. So that's this measure here. So now I have all of these individual parts. I have this 42, the 144, and this 128. To find AD, which is the one that we're looking for, this creates a full circle. So we're going to do 360 minus 42 minus 128 minus 144. And that's going to give me that leftover angle measure. So 360 minus 42 minus 128 minus 144 gives me 46. So that is the measure of that arc. And those are all of those IXLs.